In previous lecture, we have done the problem related to a de-energized condition. Now in this lecture, we are going to solve problem related to energized condition. So the question is, for the circuit shown in the figure below, find I1 ohm 0 plus, I2 ohm 0 plus, IC 0 plus, IL 0 plus, BC 0 plus, BL 0 plus, voltage across inductor at T equals to 0 plus, B1 0 plus, B2 ohm 0 plus. Similarly, we have to calculate dVc upon dt 0 plus and dIL upon dt 0 plus. So we go through step. In previous lecture, we have followed 3 steps: step 1, step 2 and step 3. In this case also we will follow 3 steps. So in step number first, we find out whether the circuit is in energized condition or de-energized condition. So if we see and observe this circuit, we know that at t equals to 0, the switch is going to open. So we can say that at t equals to 0, switch is going to open, and we can say that at t equals to 0 minus, the switch will be in closed position, and at t equals to 0 plus, the switch will be in open position. In step 1, to check whether the circuit is in energized condition or de-energized condition, we should go through t equals to 0 minus circuit. At t equals to 0 minus, the switch will be in closed position. And we can see the current will flow from higher potential to lower potential. So current will flow from this 60 volts voltage source. Current will go through 1 ohm, and from here current will divide in 2 branches. Current will flow in this 4 Henry inductor, and current will also flow in this capacitor also. So if there is current in the capacitor, if there is the flow of current in the capacitor, then capacitor will charge, and there will be voltage across capacitor. So at t equals to 0 minus, the switch will be in closed position, and we see that there is a flow of current in 4 Henry inductor, and there will be voltage across capacitor also at t equals to 0 minus. So we can say that at t equals to 0 minus, there is the flow of current in the inductor, and there is the voltage of capacitor. There is voltage across capacitor at t equals to 0 minus. So by observation, we can say that at t equals to 0 minus, there is a flow of current in the inductor, and there will be voltage across capacitor. So we can say that the circuit is in energized condition. Now in step 2, we will draw circuit at t equals to 0 minus according to previous table. So circuit at t equals to 0 minus, we will draw circuit at t equals to 0 minus with the help of table. So first of all, we will draw switch. So this is t equals to 0 minus circuit. At t equals to 0 minus, the switch will be in closed position. So this is the switch is in closed position, and there is the voltage source of 60 volt. There is a resistor of 1 ohm. Similarly, this is the resistor of 2 ohm. This is energized inductor. So energized inductor at t equals to 0 minus is replaced by short circuit. If we see table, we will know that energized inductor at t equals to 0 minus will be replaced by short circuit. Although it is replaced by short circuit, physically there is inductor. Similarly, this is the voltage source of 45 volt, and finally this energized capacitor at t equals to 0 minus is replaced by open circuit according to given table. Although this capacitor is replaced by open circuit at t equals to 0 minus, physically there is capacitor of 2 farad. Similarly, this energized inductor is replaced by short circuit, but physically there is a inductor of 4 Henry. Since in this circuit we don't have the variable of current, so we will assume the direction of current in this circuit. Let us assume the current in this branch is I0 minus. This current will flow in this branch, like in the current I0 minus will flow like this in this branch, and it will find 2 branches. Previously I said that this is open circuit, but physically there is a capacitor of 2 farad. So this current will flow, this I0 minus current will flow in this branch. Let us suppose in this branch I assume the direction of current in this direction and assume I10 minus. Similarly, in this branch, let us suppose the direction of current is in this direction, downward direction, and the variable is I20 minus. If we now in step 2, I have drawn the circuit of t equals to 0 minus according to given table in lecture number 1st. Now we will calculate this. First of all, we will calculate this branch current, that is I0 minus, I10 minus and I20 minus, and finally we will calculate, our target is to calculate the current through inductor, that is IL0 minus, and the voltage across this capacitor, that is VC0 minus. So our target is to calculate IL0 minus and VC0 minus. So first of all we will calculate this I0 minus, I10 minus and I20 minus. So let us calculate. If we see this circuit, we will see that this is open circuit. Since there is no current in the open circuit, so we can say that I20 minus is 0 ampere. I20 minus equals to 0 ampere. Now if we see this circuit, we see that in this branch there is a current of I0 minus, and this total I0 minus current will flow in this branch, and current will flow like this. Since in this branch there is no current, that is I20 minus is 0 ampere, so we can say that I0 minus will be equals to I10 minus. So we can calculate I0 minus equals to I10 minus equals to. Now to calculate I0 minus and I10 minus, if we see this circuit, in this branch there is a current of I0 minus, and in this branch due to this open, this I20 minus is 0 ampere. So we can say that this total I0 minus current will flow through this 1 ohm. In this branch will flow, I0 minus will totally flow in this branch and return to this source. So in this path, in this closed path, we can say that there is a flow of current of I0 minus, and by analyzing we can say that I0 minus will be equals to I10 minus in this closed path. So to calculate this, so we can say that I0 minus will be equals to I0 minus. I0 minus equals to I10 minus. Now to calculate this branch current I0 minus or I10 minus, we will use KVL in this closed path. To use KVL in this closed path, we need polarity, and we can find polarity with the help of direction of this current. So current enter in this resistor, so here will be positive, and current exit from this 2 ohm, and this point will be negative. Similarly, current, we know that there is a capacitor. Physically there is a capacitor. Since at equals to 0 minus, capacitor act as open circuit, but physically there is a capacitor. So we can say that current enter into the capacitor, so this will be plus, and exit, so this will be minus. Similarly, current enter into this 1 ohm, so this is plus, and current exit from this 1 ohm, so this is minus. Now we can use KVL in this closed path. So if we move from this minus to plus, so KVL in outer loop. If we move from this minus to plus, so this will be my plus, and the value of this voltage source is 45. Similarly, if we move here from plus to minus, so whatever will come at the end, that we will take the sign. So if we move from plus to minus, so we finally get minus, and the drop in this 2 ohm will be 2 into I0 minus. Similarly, if we move from this plus to this minus, at the end we get minus, so this will be minus, and the drop in 1 ohm is 1 into I10 minus. Similarly, if we move from plus to minus, this will be minus, so 60 volt. So value of this voltage source is 60, and we have written the KVL in this path. There is no any other element in this closed path, so it will be equals to 0. Similarly, 45 minus 2 into I0 minus, we know that 1 into I10 minus will be equals to I0 minus, so I1 is replaced by I0 minus 60 equals to 0, or 45 minus 60 will be equals to minus 15, and this minus 2 I0 minus 10 I0 minus is minus 3 I0 minus equals to 0. Or if we move this minus 3 I0 minus to the right hand side, we get minus 15 equals to 3 I0 minus, or I0 minus is equals to minus 15 upon 3 equals to minus 5 ampere, and this is I0 minus, so we can say that I10 minus is also minus 5 ampere. Now we have calculated this branch current, that is I0 minus is minus 5 ampere, this I10 minus is minus 5 ampere, and this I20 minus is 0 ampere. Now in step 2, our target is to calculate current through inductor, that is IL0 minus. So in since it is replaced, this energized inductor is replaced by short circuit, but physically there is a inductor. So in this inductor there is a flow of current of I0 minus, and I0 minus is minus 5 ampere. So we can say that this IL0 minus is equals to minus 5 ampere, and by continuity relation for inductor, we can say that IL0 minus equals to IL0 plus equals to minus 5 ampere. Now our another main target is to calculate voltage across this capacitor, that is BC0 minus. Since at t equals to 0 minus, this energized capacitor is replaced by open circuit, but physically there is capacitor, and now we have to calculate the voltage across this capacitor, that is BC0 minus. So to calculate BC0 minus, we have to calculate the voltage across these two terminals. So to calculate the voltage across two terminal, in previous lecture also I said that to calculate the voltage across two terminal, we should use the concept of starting point and finishing point. So here also we have to calculate the voltage across these two terminal. To calculate the voltage across two terminal, we should use the concept of starting point and finishing point. To use the concept of starting point and finishing point, we should have the polarity. We should have polarity in these two terminals. So to obtain the polarity in these two terminal, the polarity can be obtained with the help of this direction of current, which we have calculated previously. So this terminal is plus and this terminal is minus. Now we are able to calculate the voltage across these two terminal by using the concept of starting point and finishing point. So let us use this concept. So this is the starting point and this is the, let us suppose this is starting point and this is finishing point. So this is starting point. I will assume starting point as higher potential. If this is higher potential, then sign convention will be plus. So now the sign convention is plus. So the voltage, the potential of this terminal is VC 0 minus. Now we will follow any one path. So to go to the finishing point, we have two paths. One path is this is starting point and this is path and this is finishing point. And another path is, this is starting point and this, we can follow this path also, and this is finishing point. So this is higher potential, this is starting point, higher potential, sign convention is plus, and the potential of this terminal is VC0 minus. Now we will follow this path. So if we move from this plus to minus, we will get minus, and this drop in this 1 ohm is 1 into I1 0 minus. Similarly, if we move from this plus to minus, we will get minus, and this value of this voltage source is 60. And this is finishing point, and finishing point is assumed to be lower potential. If it is lower potential, then the sign convention will be minus. And this is lower potential, we assume the value of lower potential as 0, and this is equals to 0. So we can say that VC0 minus 1 into I10 minus is minus 5 ampere, minus 60 equals to 0. Therefore VC0 minus plus 5 volt minus 60 equals to 0, or VC0 minus equals to 55 volt. And by continuity relation for capacitor, that is VC0 minus equals to VC0 plus equals to 55 volt. Now we will go for step 3. In step 3, we will draw the circuit at t equals to 0 plus, and in this step 3, we will first we will calculate the branch current or loop current, and then we will calculate current through inductor, that is IL0 plus, and voltage across capacitor, that is VC0 plus. So let us draw circuit at t equals to 0 plus. So at t equals to 0 plus, the switch will be in open position. This is voltage source of 60 volt. This is voltage source of 45 volt. If we see, this is energized inductor. This energized inductor at t equals to 0 plus is replaced by current source. If we see table, this voltage, this energized inductor at t equals to 0 plus is replaced by current source. and this current source will have two things. One is direction and another is magnitude. If we see, so to find the direction of this current source, we will go for t equals to 0 minus circuit. In t equals to 0 minus circuit, the current in the inductor is in this direction, from left to right. So the direction of current source at t equals to 0 plus will be from left to right, and the magnitude of this current source, that is IL0 plus, will be equals to, for magnitude also we will see at t equals to 0 minus circuit. So at t equals to 0 minus, the current through inductor is minus 5 ampere. So this magnitude, or from continuity relation we can say that IL0 plus equals to minus 5 ampere. So the magnitude of this current source will be minus 5 ampere, and there is the resistance of 2 ohm. Similarly, there is a resistance of 1 ohm, and in this branch this is energized capacitor. So energized capacitor, if we see table, energized capacitor at t equals to 0 plus is replaced by voltage source, and voltage source have two things. One is polarity and another is magnitude. So to find polarity, we will see in t equals to 0 minus circuit. In t equals to 0 minus circuit, the polarity of this terminal is plus and the polarity of this terminal is minus. So we can say the polarity of voltage source at t equals to 0 plus will be like this. This will be positive polarity and this will be negative polarity. And the magnitude of this voltage source also can be found in t equals to 0 minus circuit. So if we see in step 2, we can see that this BC0 plus equals to 55 volt. So this magnitude will be 55 volt. This is BC0 plus. Since at t equals to 0 plus, energized capacitor is replaced by voltage source, but physically there is a capacitor. So BC0 plus equals to 55 volt. Similarly, at t equals to 0 plus, energized inductor is replaced by current source, but physically there is an inductor of 4 Henry and there is a capacitor of 2 Farad. Now let us assume the current in this branch, that is I0 plus, current in this branch is I20 plus, current in this branch is I10 plus. So let us so first of all we will calculate this branch current, and then we will calculate current through inductor, that is IL0 plus, and voltage across capacitor, that is BC0 plus. So first of all we will calculate I0 plus. So if we see that first of all we will calculate I10 plus. Since this is open circuit, we can say that this I10 plus is 0 ampere. I10 plus equals to 0 ampere. Now if we see in this branch, in this closed path, we can say that this I0 plus will be equals to I20 plus. We can say that this I0 plus will be equals to I20 plus. In this branch there is in this branch there is I0 plus, current I0 plus, and in this branch there is a current of 0 ampere since it is open. So this total current I0 plus will totally flow in this branch. So if we see, we can say that this I0 plus will be equals to I20 plus. So we can say that I0 plus will be equals to I20 plus. And if we see, if we analyze this closed path, we can say that in this branch there is a flow of minus 5 ampere. So we can say that this I0 plus is equals to minus 5 ampere. So this will be equals to I0 plus equals to minus 5 ampere. So we have calculated the branch current, that is I0 plus, I20 plus and I10 plus. All of the branch current has been calculated. Now we will calculate our target is to calculate current through inductor, that is IL0 plus equals to minus ampere, which is given here. Similarly, we will calculate capacitor voltage, that is BC0 plus, and VC0 plus is equals to 55 volt, which is given in the circuit. We have completed step 1, step 2 and step 3. Now we will calculate whatever the question has asked. We will calculate whatever the question has asked. So first of all, we will calculate I1 ohm 0 plus. So this, in this case, this I1 0 plus equals to 0 ampere. The current in this 1 ohm is this I1 0 plus. So I1 0 plus is 0 ampere. So I1 ohm 0 plus equals to 0 ampere. And voltage across 1 ohm, that is B1 ohm 0 plus, equals to current into resistance, that is current is I1 ohm 0 plus and resistance is 1 ohm, that is 0 into 1 equals to 0 volt. Similarly, I2 ohm 0 plus is equals to I2 ohm. The current in this 2 ohm is I0 plus, and this I0 plus is minus 5 ampere. So the current in this 2 ohm is I2 ohm 0 plus, and this current is minus 5 ampere. And voltage B2 ohm 0 plus is equals to current, that is I2 ohm 0 plus into resistance, that is 2, equals to minus 5 into 2 equals to minus 10 volt. Now IC 0 plus equals to the current in this capacitor is I2 0 plus, and I2 0 plus is minus 5 ampere. So IC 0 plus is minus 5 ampere, and voltage across capacitor, that is BC 0 plus, is equals to, which I have calculated 55 volt. Similarly, current through inductor, that is IL 0 plus, is equals to the current in this inductor. Physically there is inductor, so current in this inductor is minus 5 ampere. So IL 0 plus is minus 5 ampere. Now to calculate voltage across this inductor, that is VL 0 plus. So this is 2 terminal. So to calculate the voltage across these 2 terminal, we should use the concept of starting point and finishing point. So to use the concept of starting point and finishing point, we need the polarity of these 2 terminal. And to find the polarity of these 2 terminal, we can find the polarity of these 2 terminals with the help of direction of this current. So physically there is inductor at t equals to 0 plus. Energized inductor is replaced by current source, but physically there is inductor. So if this current enter into this inductor, this terminal will be plus, and if this current exit from this inductor, so this terminal will be minus. Similarly, if current enter in this terminal, in this 2 ohm, then this will be plus, and exit, this will be minus. Similarly, this current enter in this 1 ohm, this will be plus, and exit, this will be minus. So we have find the polarity in this circuit. Now we will use the concept of starting point and finishing point. Now to find the voltage across these 2 terminal, we need to use the concept of starting point and finishing point. To use the concept of starting and finishing point, we need the polarity of these 2 terminal, and we have find the polarity of these 2 terminal. Now we are capable to use the concept of starting point and finishing point. Let us assume this is starting point and this is finishing point. So this is starting point. We assume starting point has higher potential, and the sign convention will be plus. So this is plus, and the potential of this terminal will be BL 0 plus. Now we will follow one of the path. Let us follow this path. So this is, so move from this terminal, move to this part. So this is plus to minus, we will move from plus to minus, so this will be minus. Whatever will come at the end, that sign will be taken. So this is, we are moving from plus to minus, so this is minus. and the value of this voltage source is 45. Similarly, we will move from this minus terminal to this positive terminal, that is whatever will come at the end we will take that sign, that is plus, and the value of this voltage source is 55. And we will move from this minus to plus, so we will take plus and drop in this 2 ohm is 2 into resistance into current. In this 2 ohm resistor there is a current of minus 5 ampere. Now this is finishing point, and this finishing point is assumed as lower potential, and sign convention is minus, so minus. Since it is lower potential, so lower potential is taken as 0 volt equals to 0. So from this we will calculate BL0 plus equals to BL0 plus will be equals to 0 volt. So we have calculated the voltage across this inductor, that is BL0 plus. Finally, we will calculate dVc upon dt 0 plus and dIL upon dt 0 plus. So to calculate dVc upon dt 0 plus, we have ready-made formula, that is IC 0 plus equals to C times dVc upon dt 0 plus. We have IC 0 plus as minus 5 ampere and capacitor of 2 farad into dVc upon dt 0 plus. So dVc upon dt 0 plus is equals to minus 5 upon 2 equals to minus 2.5 volt per second. Similarly, to calculate dIL upon dt 0 plus, we have ready-made formula as BL0 plus equals to L into dIL upon dt 0 plus. We have BL0 plus as 0 volt and inductance of 4 Henry into dIL upon dt 0 plus. Therefore, dIL upon dt 0 plus equals to 0 ampere per second. So whatever the question has asked has been calculated, and finally we have calculated dVc upon dt 0 plus and dIL upon dt 0 plus. Thank you for today.